Students, my name is Kelly Way, and I am privileged to be your geometry teacher this year. This is your first preview video note. You should have these items on hand. The items, this would be what are called the preview video notes. You must have printed physical copies of the preview video notes. Obviously, something to write with. I recommend multiple colors. You also need your reference booklet handy. Let's get this first one started. This is Unit 1, the Alphabet and Grammar of Geometry. The preview video 1.0, the logic of geometry. And I always like to start with a short breathing activity. You should turn off all other electronics. And you're going to pause. Ready? Inhale through your nose. Hold your breath. Exhale. Do this again with your eyes closed. Close your eyes. Inhale through your nose. Hold your breath. Eyes closed. Exhale. Now sit there for 3 seconds with your eyes closed and quiet. Your brain now relaxed and focused. Let's go to your first preview video. You should have these notes in front of you. The first page always has the calendar for the unit that we plan on following, barring an act of God, something that is outside of my control. On the right-hand side is what's called the communication page. If you're ever absent and you're turning in preview notes for full credit, you will use this page right here with the date that you were absent and which video note that you are turning in for late credit, such as video note 1.2. God forbid you're absent that early, but if so, and then you check the box if you were absent and you are turning it in after the original full date, you can get potential full credit. If you were absent at home, but well enough to actually keep up with the homework and you turn in the video note when it is originally due, I'm going to bribe you with a little extra credit. Or if you were present but failed to turn it in and you're out of homework passes, you turn them in for late credit within 1 week that it is due. This is how you do the preview video notes. I expect you to write down the date, time, and location, as well as get either a parent, a guardian, or a teacher sign-off, some sort of adult that was within your earshot that can affirm that you actually did these preview notes yourself. Follow all the instructions in the video, especially when I tell you to pause the video and do your own work. It is essential that you do your own work in pencil so I can see what you did on your own, and then you correct in a red pen, something red, which I provided for you. It is totally all right if you get things wrong in the preview note. It is a learning experience, but I want it to be a learning experience, not copying. You learned how to copy when you were in kindergarten. You should be beyond that by now. Always watch, listen, and follow along. Do not mindlessly copy or simply watch the video and copy. When you're finished, I expect you to take 1 minute and summarize in your own words what are the main key things you remember from the lesson. Finally, I want the preview notes turned into the turn-in box at the beginning of every class. How are they graded? You get 1 point for date, time, and location, and a parental guardian teacher sign-off. 6 points for showing your work in detail, all steps, all computations. If at any time you actually touch a calculator, I expect you to write down even what you're calculating. I expect to see your work in pencil for computations and working out problems and correcting in a red pen. Failure to do so, I'll dock you points. And I expect a summary in your own words and your own language with some thought and reflection. This is the page we're now starting, Preview Video 1.0, the logic of geometry. Record your location, the date and time that you're working on this. Make sure you get a parent or teacher guardian sign off. Heads up. Turn off all digital distractions right now. Be solely and only focused. This little icon list, turn off TikTok, YouTube, your cell phone, Snapchat. If you're trying to play a video game and do this at the same time, stop it. If your particular digital addiction is not listed, I still expect you to turn it off and focus solely on this activity. It'll go faster. Your brain will work more efficiently. Couple reminders. I'm available for tutoring, open 1A, 1B. I'm also available lunch and after school, Monday, Wednesday, and Friday, 2:30 to 3:15. I suggest you highly subscribe to my YouTube page. So if you go to my YouTube page, I suggest you hit the subscribe button. That way you get immediate notifications when I upload new videos into YouTube. Please also subscribe to the Remind 101 text. Get your cell phones out. We did this in class. If you did this already, screen past this. For my 8A students, to the number 81010, text this. To my B-Day students, to the number 81010, text that. Pause the video and sign up for the Remind. This is blind texting system. Remember, if you're absent, you review the material, you access the material on Moodle, you print it, preferably on paper, notability if you absolutely have to. Late homework issues, I already talked about. Let's get this party started with your first lesson. This is called the logic of geometry. Keywords. Inductive. Say it with me as I highlight. Deductive. Converse, inverse, and the law of contrapositive, and conditional. So the English alphabet consists of 22 letters. Correct that. I want you to write the correct number there. Occasionally, I will write written mistakes. So those of you who are watching but not listening will only see the mistake. And if you are not listening, you would not have heard me say, correct that. So if you're just watching this, I'm smiling at you because you're copying down the wrong thing. Students, correct that number, please. You should know how many numbers are in the English alphabet. The geometry alphabet, this is correct. The English alphabet consists of a certain number of letters. Correct that, please, right here. But the geometry alphabet consists of only 5 letters. And those 5 letters are point, line, segment, ray, plane. These letters make up what we call the words of geometric diagrams. And in the English language, you learn your letters, you learn words, you learn phonics, and at the same time, you learn grammar. Which means how are words formed together to communicate coherently in sentences and complete thoughts. The grammar of geometry is logic. We are going to be talking about several logic rules today. Vocabulary, today we're going to discuss the grammar of geometry, logic. The logic terms are conditional, converse, inverse, contrapositive, inductive reasoning, deductive reasoning. You're going to need your reference booklet handy. A conditional statement is an if-then statement. Sometimes it's directly said, sometimes it's implied. It communicates the idea of cause and effect. All commercials and entertainment are essentially conditional statements. If you buy this, you'll get that. If you watch this, you will be excited or entertained. There's some sort of allure. That's the whole point behind movie trailers is here's a tidbit. And if you come, you'll experience the full lovely impact of whatever the said movie or media is. Just as here's a Walmart ad. You should have read that. And the ad says in one bit, Walmart, save money, live better. But what it's communicating is this. If you shop at Walmart, then you save money to spend on a better life. That's what it's communicating, even though it doesn't exactly say that, cause and effect. The conditional or the cause is not directly stated, but it's implied. The conditional would be shop at Walmart. That's the conditional in this advertisement. And the effect is save money, live better. Save money, live better. In geometry, we have fancy terms for cause and effect. In a conditional statement, the cause is called the hypothesis, and the effect is called the conclusion. Cause, hypothesis, effect of the cause, conclusion. Now, a conditional can be manipulated three different ways. Manipulated means switched around, and we're going to talk about that because it implies some interesting logic reflections. A conditional, a word called converse. Converse, you switch. Inverse, you switch, or, flip or invert, flip. Contrapositive, you switch and flip. Watch the hands, do it with me. You have no idea what this means right now, but you're going to do it anyways because you are the student and I am the teacher. Ready? Put your hands like this. Say converse, switch. Say inverse, flip. Say contrapositive, switch and flip. What on earth is going on? This is what's going on. If you didn't gesture that moment, you're going to be in trouble in this class because I'm going to be gesturing a lot and I expect you to follow me. It helps your brain integrate key information if you utilize both words, your eyes looking, as well as gesturing with your hands and arms. It integrates information into your brain. Let me give you a very simple example. If it is sunny this weekend, then we will go to the beach. You can think whatever your favorite beach is, Aptos, Carmel, Monterey, Santa Cruz. If it's sunny this weekend, then we're going to go to the beach. That would be a conditional statement because your cause is here. The cause is if it's sunny, and the effect is we will go to the beach. A conditional statement, okay, go like this with your hands. And we say, if it is sunny, then we go to the beach. If sunny, then beach. I'm shortening it. If sunny, then beach. We're going to switch it around. And the converse is going to read, if beach, then sunny. So the converse, you have to massage the grammar just a little bit, something like this. If we go to the beach, then it is sunny. I'm going to highlight the words here. We're going to shorten it even more. So the original was sunny and beach. And now it is beach, then sunny. That is the converse, which is the switch. Inverse means to flip or invert. Also the word negate, which means to say the opposite of, would read like this. If it is not sunny, then we will not go to the beach. Notice I'm shortening the grammar just a bit here. Don't tattletale it to your English teachers on me. So the conditional, if sunny, then beach. Converse, if beach, then sunny. Inverse, flip it. If not sunny, then not beach. Contrapositive is you switch and flip. It reads like this. If we don't go to the beach, then it was not sunny. This is an example of the logic of converse, inverse, contrapositive. Converse, cause and effect. Conditional, cause and effect. Converse, switch. Inverse, flip or negate or invert. 3 different words, same concept. Contrapositive, switch, and flip. Let's try a couple more. I want you to take this word. If you eat an apple, then you eat a fruit. That is a conditional. If you eat an apple, then you eat a fruit. I want you to write out the converse, inverse, and contrapositive of that statement. Pause the video. Welcome back. Students, you should have written in pencil, and now you're getting out your red pen and correcting. I want to see the red pen corrections. So your converse should read something like this. If you eat a fruit, then you've eaten an apple. Notice again, I'm shortening the grammar to get down to the main idea. If you got that right, I want a star, smiley, some sort of I'm an amazing student kind of a thing. If you got it wrong, just correct yourself in red so I can see the difference. The inverse is if you did not eat the apple, then you did not eat fruit. Contrapositive. Switch. The first one is apple then fruit. Contrapositive, you switch and flip. So if you don't eat fruit, then you've not eaten an apple. Okay, you're like, a couple of these doesn't make sense. If I eat a fruit, I haven't always eaten an apple. We're not asking whether or not it makes logical sense right now. Right now, you're just manipulating according to the words converse, inverse, contrapositive. Now, logic. Here you go. Now we're going to talk about what is the truth value of these logic manipulations. Here's the truth value. Your original conditional statement was, if you eat an apple, then you eat a fruit. You ask yourself, is that a true statement? And when we say true, we mean always true, no exceptions. And yes, if you've eaten an apple, you have eaten a fruit. That's always true. So we check true. Let's try the converse. Converse says, if you eat a fruit, then you eat an apple. And you're like, well, what if I'm sticking a banana in my mouth or pineapple or a strawberry? That's not going to be always a true statement. So we don't say sometimes true. If it's not always true all the time, we have to check the word false. Inverse says, if I don't eat an apple, I don't eat a fruit. Again, that would be false. You could be eating blackberries. The contrapositive, however, says, if you don't eat a fruit, then you don't eat an apple. If I say, I am not eating fruit all day, then you will never be eating an apple. That is a true statement, which shows this relationship. If your original conditional is a true statement, only the contrapositive is always also going to be a true statement. Converse and inverse are like, maybe, sometimes not. Okay, so right down here, if a conditional is true, only the contrapositive is forced to be true. But when a conditional and its converse together are true, then you have what's called a biconditional statement. Now we're going to talk about inductive and deductive reasoning, which is a type of logic. Those were logic manipulations. Now we're going to talk about types of logic. Take a look at all these photos of golfers, several of them. Just take a look. Just make an observation. Let's say you were to attend hundreds of golf matches and you were to notice this every single time, or like 99.9% of the time, like, I noticed something. And you should have noticed in every photo there is a hat, cap, whatever you want to call it, sun visor. There's something to keep the sun out of the golfer's eyes, which makes sense because golf is needful of vision and accuracy and hand-eye coordination. So not being distracted by rays or blinding sun is important. So looking at this, you could imagine knowing nothing about professional golf attire. You decide all the professional golf matches in a year. You observe every golfer's outfit closely. After observing hundreds of professional golfers, you conclude that if someone is in professional golf attire, he or she always wears a hat on the course. Therefore, you come to a general conclusion that all professional golfers wear hats on the course. This, what I just did, is called inductive reasoning. Go like this with your hands, like this with your hands again. Get used to gesturing. Say, take in observation. Say, in observation. Now go, aha, truth. That's inductive reasoning. You take in hundreds of observations and you come to a general truth. All golfers wear hats on the course. That's inductive reasoning. So, deductive reasoning. Deductive reasoning is different. Let's differentiate. Inductive, you take in observations and you come to a general truth. I call it the aha. That's inductive reasoning. Deductive reasoning takes the general truth, the aha, and applies it to a specific situation or person or problem. So you take the aha and you apply it to a specific situation. That's deductive reasoning. Let me give you an example. Back to the golf example. After multiple observations, you come to the conclusion that all professional golfers wear hats on the competitive course. Let's say you meet Mr. Tinvu at a restaurant, and he tells you that he is a professional golfer. He is sitting in a restaurant in a full suit and tie. What assumption could you make about his choice of clothing when he's on the golfing green? And if you're following the line of logic, even though at that moment, Mr. Vu is not wearing a hat, you could safely assume that on the golfing green, he wears a hat. Mr. Tinvu, that is a specific application. That's called deductive reasoning. Inductive reasoning discovers truth. Deductive reasoning applies truth to a specific situation. I'd like you to take a moment, read through these two paragraphs and check whether you think they're inductive or deductive reasoning. And I'd like you to underline the key phrases or words that lead you to believe inductive or deductive reasoning, which means the lack of underlining means you're not listening to instructions. So pause the video. Welcome back again with a red pen. You are correcting your work. And in this one, right here. You know that all Olympic athletes must win at a national level prior to competing in the International Olympics. Gabby Douglas competes in the 2016 Olympics. Therefore, you conclude she must have won a U.S. gymnastics championship at some point. That would be deductive. Why? Because you started with a truth, and you applied it to a specific athlete, Gabby Douglas. You are testing a hypothesis that the rate of a falling item does not change depending on its mass. From same height, you conduct hundreds of experiments, dropping items, and you conclude they fall at the same rate regardless of mass. You discovered truth through observation. That should have been inductive. If you got those wrong, make yourself a little note in red pen. What do you want to remember next time? Good news for you in geometry. The vast majority of what we work with, the discovered truth, the inductive reasoning part, has been solidified over literally thousands of years by hundreds of mathematicians worldwide. Here are some only highlights. A few of these you may know: Pythagoras, Plato, Euclid, Hypatia, Brahmanputra, and Khayyam. These are famous mathematicians who have codified various geometric discoveries. So they have gone through the hard process of discovering truth. And then you, as geometry students in this modern age, are taking those truths and applying them to specific situations. But before we talk about geometry, which is not familiar to you, we're going to briefly review some mathematical truths that you are familiar with through algebra. You are going to get your reference booklet out, please. You are turning a few pages. You are finding Unit 1, the alphabet and grammar of geometry. You're turning a page. This is called the scribe page. First page of your Unit 1 test, that's filled out. Here's some blank pages for you to practice with. That's 5% of your test. You are flipping through, and we are right here under algebraic properties. So we're going to write down what are some of the discovered truths of algebra that you are already familiar with. So we are going to use these logic rules in class. I want these written in your reference booklet. Ready? You're already familiar with these. When I draw, you draw. Distributive property. You circle and draw distributive lines. And of course, you take the next step. When you do distributive property, circle, distribute, 2 lines. Addition and subtraction of real numbers. You're working on one side only of an equal sign. So if I have 5x minus 2x equals 12, you also know this as collect like terms. This would be like this. Notice you're only working on one side of an equal sign. Here is an example of multiplication and division of real numbers. If we are on one side of the equal sign and we are multiplying, you can reduce and cancel on one side of the equal sign. So like this, 2 goes into 16 8 times. 5 goes in here 3 times. 5 goes in here 4 times. So if I were to actually multiply this out, my x would be, that's a 1 and a 3, would be 3 over 4 times 8, 32. That would be an example of multiplication and division of real numbers. Not to be confused with the addition and subtraction property, where you are crossing the equal sign. That's where you're working on both sides. So this 5x minus 2, if I were to solve this algebraically, I would go plus 2 to both sides. I want you to write it down. And we get 5x equals 10. That is called addition or subtraction property, both sides of the equal sign. Here's an example of multiplication and division property. I got 1/4 x equals 10. If I want to solve for x here, I'm going to multiply both sides by its inverse, which is 4 over 1. And 4's cancel. So I get x equals 40. Here, I want to solve for x. I divide both sides by 6. Notice both sides. X equals 6. That is an example of multiplication division property. Flipping it over. Nope, we're flipping this way. Cross multiplication. Warning, what I'm about to do is incorrect. Don't follow, just watch. Oh, I've got a 10 and an 8. 2 goes into both, so I cross it out, put a 5, cross it out, put a 4. That is incorrect. And the reason why that's incorrect is you cannot cancel across an equal sign. You cannot cancel across an equal sign. Think of an equal sign as this is your backyard, this is your neighbor's backyard. You cannot take stuff away from your neighbor, but you can be really nice to your neighbor and multiply. Cross multiply. So you can cross multiply, but not cross cancel. Over here, if I were to do this, I want to see that 9 on the outside of a parentheses. Do not both cross multiply and distribute in the same step. 5 outside those parentheses. Do not cross multiply and distribute in the same set. It's called cross multiplication property. Substitution property, real simple. Oh, I skipped one. Square root property. X squared equals 64. The opposite of squaring is square rooting. X would equal 8. Not if I had x squared equals 64. The opposite of squaring is not dividing by 2, because in this case, you would get x equaling 32, and this would be incorrect. The opposite of squaring is square rooting. The opposite of square rooting is squaring. So I would go like this to undo that square root. I'd square both sides. So I get x equals 6 times 6, which is 36. Substitution property. If you have 3x and x is 8, you substitute. Notice I actually circled and drew a little arrow. I expect you to do that as well. That's 3 times 8 equals 24. Properties with variables, the last one, x plus x. It's 2 x's, x times x, x squared. These are the deduced logic properties common to algebra that you must be familiar with. Here you go, students. Now summarize some of the key points in today's lesson in your own words. I'm not looking for little tiny words here. I'm looking for complete sentences. Keep that in mind.